Hello, Maydelis. Thank you for your questions. Please notice that when you punch on an individual question, there's no way for me to navigate for other questions. All I see on these when it shows up is the question you're actually asking about. And I know that you're having some issues trying to figure this one out. And it does ask you to use a graphing utility, and so you'd have to go find a graphing utility somewhere on the web. But beyond that, let's take a look and see what else we have here. I like your answers right here. You were able to figure out the first one. And even if you couldn't figure out what the local maximum was, you could use that information to find the local minimum, because this is odd, right? Odd degree, you add both of them as odd, and so you have that reflection across the origin, meaning if I have a local maximum of positive 5, I will have a local minimum of negative 5. If it occurs at x equals negative 1, then the maximum is going to occur at x equals 1.4, positive 1. Because of the nature of odd functions. We have the reflection across the origin, right? Okay. Beyond that, the end behavior was enough to be able to pick out these graphs. I hope you noticed that, right? This leading term, just from this, had a positive coefficient, so it ended up going to the up on the right, which meant this answer had to be wrong, and this one was possible. But also because it's odd, it should be going to negative infinity, going down to infinity on the left, and that was the only one of these that had the right end behavior. It also has the right y-intercept, too, because I can see that the constant term there is just missing. So that right there, you didn't actually need a graphing utility to figure out what the graph would look like. You did need it for this part of the question. Well, let me do a similar exercise, so we can see how that works, okay? I'll run through on this. So the first thing I see is, oh look, another odd function. I know this has to rise to the right and fall to the left. This one, this one, this one are my three choices. This one goes the opposite direction. And this one, well, it just doesn't. It doesn't have the symmetry. This has odd symmetry, and this does not have the symmetry across the origin. So this was the only possible answer on this, even without looking for that. Now, the maximums, yeah, you have to check this. I can see from the way this one's set up, I could have just gone looking for a graphing utility. I don't know if you did this or not. When I do these myself, I usually look for the Wolfram. I use Wolfram Alpha. I know a lot of you guys like Mathway, but it feels kind of juvenile to me. You get a much more mature product with Wolfram Alpha if you want to use that for helping you out with your homework. So I'm looking at 2x to the 5th minus x cubed. But as I'm looking at that, I'm also seeing how that's going to, that 2x to the 5th minus x cubed, and I can see this as I'm looking at it, as this is something that's going to factor. It's x cubed, that's 3 zeros at 0, times what? 2x squared minus 1. And from this I can see roots at plus or minus 1 over root 2. Yeah, the roots here are going to be plus or minus 1, the square root of a half, or 1 over root 2. In any case, so I can see that it has 3 roots at 0, and these 2 roots that are nice and symmetric are plus or minus 1 over root 2. And that's what I'm expecting to see. But I'm not going to be able to see where the maximums and minimums are for those, just where the roots are. The maximums and minimums are going to be between these roots, so I can kind of see it from the graph. If I run this through, and there it is. And so I can see there's one of the maximums, and there across the origin is going to be the minimum, right? Where exactly it is, well, that's what the graphing utility will help you do. And if I look at, there's the roots I told you about, 0 plus or minus 1 over root 2. And if I run all the way through on this, it will actually show me where the maximums and minimums are if I let it. Yeah, there they are. And here's where it ran through, and it found those maximums and minimums, and it gives us these nice, really clean, exact answers. But it's asking for decimal places, so you'd have to, on Wolfram Alpha, you got to click a button that says approximate form to get these. And I'd see these numbers showing up. So the maximum here is at 0.0657. What was it asking for? 2 decimal places. And so the maximum here is at 0.065. It wants 2 decimal places. That's 0.07. 0.07, and it occurs at x equals negative 0.55. And that's for the maximum. Negative 0.55. Negative 0.55. Officially, your spec sheet puts zeros in front of decimal places, but I never do because it's not important. Make sure I round it correctly. .067, negative 0.55. That looks good. And then the minimum that's going to ask for next is just going to have reversed signs on those, right? So the local minimum is going to be at negative 0.07, and at x equals positive 0.55. So we'll check that and continue. Now, where is it increasing and where is it decreasing? Let's look at the graph again, right? If I look at the graph, I can see that it's going to be increasing up to the maximum, decreasing from the maximum to the minimum, and then increasing from the minimum to infinity again, right? So it's decreasing just in its range from maximum to minimum. Everywhere else it's increasing. Okay. So where's the graph increasing? It's increasing everywhere except from x equals negative 0.55 to x equals 0.55. That means, there it is. And that was a really weird answer there. Oh, and it's saying just on that particular interval from negative 2 to 2, the entire graph for the entire function is going to be increasing all the way from negative infinity to negative 0.55, and from 0.55 to infinity. But inside this range, from negative 2 to 2, yeah, that's where it's increasing. And everywhere else is going to be. And in the middle, it's going to be decreasing from negative 0.55 to 0.55. Notice that these intervals don't include the endpoints, because at those two endpoints instantaneously, it's going to be constant. Right? Okay, and that was the whole problem on this one. And again, if you need help on these other questions, because I can't navigate to them from here, you need to punch the button on those questions as well. Don't ask me to do the extra work on this, okay? Yeah, I've got more students than you have professors. Or see me after class, and we'll go down to the lab, and I'll help you out with these, okay? I'll talk to you soon. Take care. Bye-bye. Stop recording.